Hi, welcome to this lesson on plots and outliers. In previous lessons, you learned about measures of central tendency and the spread of data. These can give us insights into how our data is formed. There's another topic that can greatly help us with this endeavor: visualizing our data. With charts and plots, you can quickly gather a lot of insights in your data. People are, after all visually oriented. So let's get started. First of all, let's take a look at the charts and plots when you want to visualize categorical data. It's data that doesn't have a meaningful order or consistent spacing. Think back to my example in the second lesson about the favorite type of food: pasta, rice, or mashed potatoes. This is a good example of categorical data. Another example would be recruitment channels. Which recruitment channel receives the most qualified applicants? Is it LinkedIn, the traditional job boards, referrals, the company website, recruitment agencies, or college recruitment programs? There are dozens of ways that you can use to visualize this type of categorical data, but to keep it simple, I'll start with the most used one: bar charts. A bar chart plots data using multiple bars to visualize the difference between categorical variables. On the x-axis, the horizontal axis, we can see the categorical variables: LinkedIn, job boards, referrals, company website, agencies, and campus programs. The y-axis, or vertical axis, shows the number of qualified applicants. Now you can add more information to these bar charts. For instance, you can change the y-axis to the total amount of applicants and differentiate in the bars between qualified and unqualified applicants. This will create a stacked bar chart. This shows us that suddenly job boards take the first place. However, on closer inspection, you can see that this is mainly due to the high amount of unqualified applicants. It's a great way to add more information to your charts, but I would be cautious with this. With visuals, there's always one key rule: more is not always better. In the words of Antoine de Saint-Exupéry, perfection is attained not when there is nothing more to add, but when there is nothing more to remove. Similar to bar charts, we have histograms. Histograms are incredibly useful and one of the most used data visualizations. It looks similar to a bar chart, except for one major difference. The x-axis is now a continuous variable instead of a categorical variable. Continuous variables are variables that have an infinite number of values between the minimum and maximum values. Examples of continuous variables are height, age, year, weight, etc. This allows us to squish the bars together, as one bar flows into the next bar in a continuous manner. Let's use the example of turnover in our company. The x-axis represents after how long a person leaves the company, and the y-axis the number of people who leave. This will allow you to gain insights into the years in which people are most likely to leave. As can be seen, there's a high turnover in year 1 and year 4, with a slight bump in year 7 as well. A high turnover in the first year may indicate a bad selection or onboarding practices, and a high turnover between 3 and 4 years may indicate low internal promotion chances. It's important to note the bar width here. I've specifically chosen to look at this data on a yearly basis. If I were to show turnover on a monthly basis, making the bars smaller, or on a 5-year basis, making the bars bigger, I would be unable to see the underlying pattern of the data. Think carefully when creating a histogram what type of answer you're looking for, and make the histogram reflect that answer. Now let's take a look at pie charts. Pie charts use the relative frequency of categories to portion out pieces of a circle, just like a pie, hence the name pie charts. So, in continuation of our bar charts case, LinkedIn gets the biggest piece, as they had the most qualified applicants of all our recruitment channels. This is followed by job boards, referrals, recruitment agencies, the company website, and finally, college recruitment programs. There are a few key things to keep in mind with pie charts, however. First, visualize no more than 5 categories per chart. It's difficult to differentiate between small values. Depicting too many slices decreases the impact of the visualization. If needed, you can group smaller values into an other category, but make sure it does not hide interesting or significant information. Second, don't use multiple pie charts for a comparison. humans are bad with quantifying areas with a round shape, making comparisons between pie charts difficult. In this case, use a stacked bar chart instead. Third, make sure that all the data adds up to 100% and that the pie slices are sized proportionally to their corresponding value. Fourth, order slices correctly. Place the largest section at 12 o'clock, clockwise. Then, place the remaining sections in descending order, going clockwise as well. Here is an almost perfect example of a pie chart, about a pyramid basking in the sun. Take note here. While pie and bar charts are useful, they're pretty bad at showing continuous data, such as tenure. For this, we use other types of visuals, such as the previously mentioned histograms, but also box plots, line charts, and scatter charts. Let's start with line charts. Line charts are one of the most well-known charts and are used when you have a continuous data set. With line charts, you connect a series of data points with a straight line. They are best suited for trend-based visualizations of data over a period of time, or to compare groups, such as here. It allows for easy comparison with performance between several departments. Both axes are continuous, and the x-axis often represents time. In our case, performance is our continuous variable on the y-axis, and tenure is our continuous variable on the x-axis. Next, there are scatter charts. Scatter charts are primarily used for correlation and distribution analysis. In most charts, you'll find your dimension on one of the axes, but for the scatter charts, the dimension is represented by the points in the charts, and the measures are found on each of the two axes. This allows you to easily see, for instance, how performance and tenure are correlated with each other. They're also a great way to visualize outliers. When a third, optional measure is used, its value is reflected in the bubble size. A great example of this is by the late statistician and brilliant visualizer Hans Rosling, on life expectancy and GDP, where the size of the bubbles reflect the size of the country. We'll link to this video in the course material. Finally, let's move on to one of my favorite data visualization methods, box plots. These tiny plots bring with them a wealth of information. Box plots use the interquartile range, mentioned in the previous lesson, to visually display our data. The box has two major parts, the box and the whiskers. The box is a rectangle that stretches across the interquartile range of our data, from Q1 to Q3. As you can see, there's also a line that splits the rectangle in half, which is the median. If one of those halves is larger than the other, that quartile has data that is more spread out, since each quartile has the same number of data points. The ends of the box plots, also called the whiskers, are for data within 1.5 interquartile range of the lower quartile, Q1, and 1.5 interquartile range of the upper quartile, Q3. Any data that falls outside of this range are what we call outliers. Outliers are values that are distant from other observations. They are rare, but not impossible, and it's up to you to figure out whether you want to include these outliers in your statistical analysis. Remember what I said in the lesson on measures of central tendency about the mean? The mean is susceptible to outliers, so excluding an outlier can be helpful in making your analysis more robust, especially when the outlier may be the result of flawed methodology. However, an outlier may also simply be an exceptional data value, an accepted exception that we can learn from. Leaving it out would make your visualization less informative and would exclude a data point which should, in all fairness, be included. Let's take a performance management example. Here you can see a box plot that looks at the performance of two junior sales teams, expressed in number of deals from 1 to 50. As you can see, Group 1 has a higher median than Group 2. However, what you can also see is that the box part of Group 1 is a lot smaller. The squished nature of the box plot shows us that Group 1 have a relatively similar performance. Group 2 is more spread out, which means that the employees in Group 2 have a larger variance in their performance ratings. There is a relatively larger difference between employees in Group 2 than in Group 1. You can also see that both groups have a positive skew, as the median is much closer to Q3 than it is to Q1 in both cases. Like I said in the previous lesson, this is to be expected with performance reviews. Now you can also see an outlier in Group 2. Someone performed really well. What could be the cause of this? Now this will be a good time to look at your data to see what the cause of this outlier is, and whether you should include them or not. It could be that a senior sales employee snuck into your dataset and outperformed all the junior sales employees. As you're only interested in junior sales employees, it would be better in this case to exclude this data point. However, it could also be that a junior sales employee simply performed really, really well. Excluding them would make your analysis less informative, so it's best to include them in this case. There are multiple methods of excluding outliers. We will link to some of these methods in the reading material below. That's it for this lesson. To sum up, we talked about bar charts and histograms, pie charts, line and scatter charts, and finally, we talked about box plots and outliers. In the next module, we'll talk more about methodology. Gathering data may seem easy, but there's a lot of things you have to keep in mind. What are the variables I want to include, and how do they differ? Do I want to use an interval variable in my survey or a categorical? What sampling methods are available? Finally, we'll also talk about probability and statistical significance. See you there.